This is the second half of review test number 1 from Thursday. We're going to go over a few of these problems here as well. So our first few questions on this page are all making some sketches. They don't have to be perfect, but some quick sketches that have a couple of labels on them. So the first graph we can see, if you look at the exponent, we're looking at an odd power function. An odd power function is this type of shape generally, and we have to decide where it's going to be moved. So the -2 inside means that we're going to shift to the right 2, and the -6 on the outside means shift down 6. That needs to be the point that's at the middle of our graph. So we're looking for something along those lines. You don't have to label anything else. That's all the points that we really need for that to get a decent sketch. The second graph, the shape we're looking at is the absolute value. Absolute value we saw earlier in the year is a V shape. The only transformation that's taken place here is the +2 on the inside, which means shift left 2. It's like the vertex that we see with the parabola, or this is also a vertex. Just shift the V left 2, and that's our graph. Number 3 is again absolute value. We're working with a V shape again. However, this time there's a shift to the right 4, and there's a shift up 5. That's where our vertex of our V shape or absolute value graph needs to be, and our graph should look something like that. Number 4, we're looking at a parabola. There are two changes to this parabola, or transformations. One is that we're going to shift the vertex up 6. And the second, the easy one to miss, is that there's a negative in front, which we know means that there's a reflection specifically over the x-axis, which sometimes we just say that it's flipped over. So we have our vertex at 6 and an upside down parabola. Number 5, again, all of these are looking at some transformations. We see that we have a movement that is taking us to the right 3 and down 7. So we're going to go right 3 and down 7. And that's going to be either the vertex or maybe the middle or the starting point of our graph, and we have to decide what shape we want to lay there. So to do that, we want to look at the fact that we are looking at a radical, that's that symbol or root, and the index, this little guy there is called our index, and decide if it's even or odd. So the number is 3. 3 we know is an odd number, so it's an odd radical, which is that shape that we've seen before. Number 6 is a little bit different. We aren't here in the vertex form or a translated type of form. Instead, this is our factored form. Factored form in any polynomial is telling us the x-intercepts, and you want to think about what number could x be to make this first factor 0. Well, I know that if x was 3, 3 minus 3 is 0. So I know I have an x-intercept at 3. Same idea for the next 2. In the second factor, if x was -2, -2 plus 2 would be 0, so I have an x-intercept at -2. And our last one, we have a value that if we let x be 4, 4 minus 4 would be 0, so there's an x-intercept at 4. So we've got 3 x-intercepts, 1 for each factor. The fact that there are 3 x-intercepts also tells us that the degree is 3. Remember, the degree is what would happen if we multiplied it out, if we put it in standard form, what the highest exponent would be. And if you imagine multiplying these all out, you would have an x times an x times an x. There would be x cubed, which means that we are looking at an odd shape graph, or odd power graph. So we're looking at this shape. So end behavior on the left, we go down. On the right, it's up. None of these have exponents, so we don't have to worry about any of them bouncing. They all cross at the x-intercept. Something like that. And the last two, our graph here is a square root graph. The index here, if you wanted to put one there, would be 2. We are moving right 7, and this +2 that's written at the front could also be written at the end, and that's how we've seen it most often in class. So we have up 2, and that's our even radical shape. The last graph, we shift right 1, down 4, right 1, down 4, and we're looking at a parabola, so get a graph like that. On the back of the page, we are looking to write an equation for the first graph that's given. There's a few things we want to pay attention to. First off, the easiest way to start our equation is to recognize how many x-intercepts there are and what type of x-intercepts there are. So there are 3, all of which cross, so we don't have to worry about any of them bouncing or adding an exponent. And I'm going to give this function a name. Let's call it g of x. So g of x is equal to, and I know that I'm going to have from the minus 6 x-intercept an x plus 6, an x plus 1 from the minus 1 x-intercept, and an x minus 2 from the positive 2 x-intercept. And I have to decide, do I need to put a number in front? And you always want to think about that, because often it's going to happen, and if you don't include that, it's not going to match the graph we have made. So looking at our equation, as it stands right now, a little bit of side work. If I plug in 0, I'll get 6 times 1 times negative 2, which is negative 12. So our y-intercept in our equation right now is negative 12. If you look at our graph, the y-intercept is 6. Those aren't the same, which means we need to do something to stretch or shrink the graph to make them match. I want to think about what could I do to negative 12 to get 6. And if we do this, divide by negative 12, you can see that 6 over negative 12 is the same thing as negative a half. We have to put a negative 1/2 in the front. That's our equation in factored form. You can also notice by looking at the graph that it's up on the left and down on the right. That is a negative odd-powered shape. So you know that you have to have a negative in front. To put this into standard form, we're going to have to distribute. Remember, don't try to distribute everything all at the same time. Instead, we want to pick two of the factors, say x plus 6 and x plus 1, and multiply them. So we have x times x times 1, 6 times x, and 6 times 1. You combine like terms, you're going to get x squared plus 7x plus 6. And we still have that x minus 2 that we didn't do anything with. I'm going to leave that negative a half out in front until the very last chance I have. So now I'm going to distribute the x to each term and the negative 2 to each term. We have x cubed plus 7x squared plus 6x. I've distributed the x to each of them. And now the negative 2. Negative 2x squared, negative 14x minus 12. I can combine like terms. I only have 1x cubed, but I have an x squared and another x squared. They combine to give me 5x squared. I have 6x and negative 14x. That's minus 8x. And the 12 is the only term that doesn't have an x in it. And now I'll take a half of each term. So negative a half of x cubed plus 5. Sorry, it shouldn't be plus. We want to make sure as we're distributing that that negative comes with us. 5 halves x squared plus 4x, remembering that negative, and plus 6. If you want to write any of those as decimals, that's also fine. Question 10, we're going to use the graph there on the right to write our equation. The first thing we want to know is what type of graph are we dealing with. So we see a V shape here. There is a constant rate of change between our points, which means I'm looking at an absolute value graph. You can write it as a function equation or just an equation with y, but it does ask us specifically to have an equation, so don't forget to have your equal sign. I know that this graph, usually the parent function has a y-intercept, x-intercept, or vertex at 0, 0. But we've shifted right 2, so I'll do minus 2 inside, and up 6, so I'll do plus 6 on the outside. And that accounts for the vertex, that accounts for the shape, but there are two other things we want to pay attention to. One is the amount that we are going down on the graph each time. Over 1, down 3, over 1, down 3. That means the slope is 3 or it's been stretched by 3. And the fact that it's upside down means that needs to be a negative 3. And that would be our equation for that graph. Last question on the test. We're looking at a parabola. We're told that it's a parabola, and we're looking to write the equation in vertex form. So we have vertex form is going to look something like that. We have to decide what is the vertex. Well, looking at our graph, the vertex here is negative 6, negative 8. That means we're going to have shifted left 6 to negative 6 and down 8 to negative 8. The last thing we want to do in our equation is decide how much do you go over and up each time. And we can see we go over 1 up 2, over 1 up 6, over 1 up 10. And we know with a parabola what we're looking for is a pattern of 1, 3, 5, 7, 9, and so forth between points. Instead, we have 2, 6, 10. Well, 1 times 2 is 2. 3 times 2 is 6. 5 times 2 is 10. And if there was space on the graph, we would go up by 14 the next time. Because each of these is multiplied by 2 or stretched by 2 in the y direction, we put a 2 in front. Part B asks us to write the equation in standard form. Very similar to the work we did earlier. If we look at the top of the page, we're looking to distribute and multiply everything out just like in question 9. Here, what we're going to do is start with the parentheses, and I've got x plus 6 squared. Remember, x plus 6 squared means x plus 6 times x plus 6, not just putting the squared on the x and putting the squared on the 6. So x plus 6 times x plus 6 is x squared plus 12x plus 36. All right, we want to get into standard form, so we have to deal with the 2 and the 8 at the end. Order of operations says going to worry about the parentheses first. We took care of our exponent, so the 2 is going to distribute inside. We have 2x squared plus 12x plus 72 minus 8. Last thing, we can combine like terms. The 72 and the minus 8 combine to 66. Nope, it should be 64. Sorry about that. And the last question, write the equation of the parabola in factored form. We said earlier that factored form tells us the x-intercepts. So if we know the x-intercepts, which in this case were -8 and +4, then we can write our equation as x plus 8, x plus 4. And if there was a 2 in front in standard, if there's a 2 in front in vertex, then there will also be a 2 in front in factored. And that is the second half of the first review test.